Ever slam on your brakes and feel that screech? You know that sound, right?
Oh, yeah.
Or maybe you've wrestled with a stubborn drawer like it just won't budge.
Yep.
That, my friend, is friction doing its thing. And today we're diving deep into the science behind it. We've got this textbook chapter here all about friction, and we're going to break it down.
Sounds good.
So friction, what exactly is it?
Well, at its core, it's all about surfaces.
Yeah.
How they interact. Anytime two surfaces touch and try to move past each other, bam, you've got friction. It's that force pushing back, resisting the motion.
Okay, so like when I'm trying to slide that darn box across the floor,
Exact.
feels like it's glued down sometimes.
It's those tiny imperfections, those little bumps and ridges on the box and the floor. They get caught on each other. Like, imagine puzzle pieces kind of interlocking.
So the rougher it is, the more those puzzle pieces lock up.
Precisely. More friction, harder to move, smooth surfaces, less friction, things slide easier.
Makes sense. So this whole friction thing's kind of a big deal then, huh?
Oh, huge. I mean, imagine a world without friction. You try to walk, you just slip and slide everywhere.
Okay, no thanks.
Can't hold a pen, can't even stand up straight. Everything's just constantly in motion.
Oh, that's just terrifying to think about.
Yeah.
So how do we actually see this friction thing in action? The textbook mentioned something about an experiment with a brick.
Ah, yeah, classic demonstration.
Yeah.
You've got your brick, right? And you tie it to one of those spring balances. Then you try pulling it across different surfaces.
Okay, what kind of surfaces?
So you could try a smooth floor first, then maybe a rough jute bag, and finally something really slick like a sheet of polythene. What you'll find is the force you need to pull that brick. It changes depending on what it's sliding on.
So the rougher it is, the harder you got to pull.
Exactly. And that spring balance, it'll show you a higher reading, meaning there's more friction at play.
That makes sense with all those puzzle pieces we were talking about.
Yeah.
Like that jute bag with its rough texture. Definitely more friction there than on a smooth floor, right?
Absolutely. And it's something you see all the time. Like, say you're trying to move a piece of furniture across a wood floor. It's tough, right? But lay down a rug. Suddenly, it's way easier.
Oh, yeah, for sure.
That rug, it's changing how those surfaces interact. Less friction between the furniture legs and the floor. It's a neat trick.
So friction, it's a bit of a double-edged sword then, isn't it? Sometimes it's helpful, sometimes it's a pain. Like, think about holding a glass,
Good point.
a rough mug, like one made of clay that's easy to grip, but a smooth, slippery glass.
Way tougher.
Almost dropped one the other day.
And you know why? Friction. That rough surface of the mug, it gives you more grip, more friction to hold on to.
Makes sense.
And this brings up two important types of friction. You've got your static friction,
Okay.
and you've got your sliding friction. Static friction, that's what you got to overcome to start something moving. Like pushing that heavy piece of furniture takes a lot more effort at the beginning, right?
And to get it going.
Exactly. Once it's moving, though, it's easier to keep it going.
True.
That's your sliding friction, the force that's working against the continued motion. Always less than static friction, which is why starting is always the hardest part.
Uh-huh. No wonder rearranging my furniture feels like a full-body workout every time.
Uh-huh.
But sometimes, don't we want less friction? Like, wouldn't things be easier if everything just slid around effortlessly?
Well, not always. Friction, as much as it can be a pain, it's got its downsides too.
How so?
Well, think about your shoes. You know how the soles wear down over time?
Yeah.
Friction, those steps you see, especially on like an overpass, all worn down, friction again.
Huh. Never thought of that.
Constant rubbing, surfaces grinding against each other. It's a battle of attrition out there.
And all that rubbing creates heat too, right? Like, ever touch the bottom of your blender after making a smoothie?
Yeah,
Hot.
exactly. All that energy, all that rubbing, it's got to go somewhere. Friction turns it into heat.
Wow. So friction is more complex than I thought. We've established it can be both good and bad, but it's pretty amazing how we've learned to work with it. Like, you see those grooves on the bottom of your shoes?
Yeah.
Those aren't just for looks, are they?
Nope. Those treads, that's all about increasing friction, giving you more grip. Especially important on slippery surfaces, like when it's raining.
So that's how I don't end up flat on my face.
Exactly. Same idea with car tires, those grooves and patterns.
Oh, yeah.
More contact points, more grip, better control.
So we add grooves to get more friction. But then there's the opposite. Like, we put powder on a carom board or oil those squeaky door hinges
That's
to reduce friction, right?
Now you're getting it. We've learned how to play with friction, use it to our advantage.
Pretty clever, if you ask me. But before we get into the hows and whys of lubricants and how those actually work to reduce friction, let's talk about an invention so simple, yet so revolutionary that it changed the way we move. You're talking about the wheel, right? Talk about a game changer. I mean,
Yeah.
something so simple, but it completely revolutionized how we get around.
You got it, the wheel. And you know what makes it even better? Ball bearings. Those tiny marvels, they ushered in a whole new type of friction rolling friction, way less of a struggle than sliding friction. Think about it. Dragging a heavy suitcase across the floor, ugh, nightmare.
The worst.
But put that same suitcase on wheels. Piece of cake.
Exactly. No way I'm going back to those clunky suitcases without wheels. And it's not just luggage, it's everywhere. Cars, bikes, skateboards.
Exactly. You see it all over, from transportation to those smooth gliding drawers in your kitchen, even ceiling fans spinning effortlessly overhead. It's all thanks to wheels and ball bearings minimizing that friction.
We've really learned to work with friction, haven't we? Finding all these clever ways to use it to our advantage.
Yeah.
But so far, we've mostly been talking about solid objects. What about when it comes to things like air and water?
Ah, good point. That takes us to fluid friction, or as it's more commonly known, drag. See, even fluids like air and water, they put up a fight. They resist anything trying to move through them. That's why swimmers feel that pushback in the water.
And why cyclists have such a tough time with headwinds.
Exactly. Even just walking around, we're dealing with air resistance, whether we realize it or not. And the faster you go, the stronger that drag force becomes, which is why you see such a focus on aerodynamic designs for things like airplanes and cars. Got to cut through that air as smoothly as possible.
Right? Those sleek aerodynamic designs, they aren't just for show, are they?
Not at all. They're all about minimizing that drag, squeezing out every bit of efficiency. And, it's pretty amazing when you think about it. We've actually taken a lot of inspiration from nature in this area.
Yeah.
Look at dolphins, for example, or the shape of a hawk's wings.
So streamlined.
Millions of years of evolution, and nature's come up with these incredibly efficient designs that cut through air and water like a hot knife through butter.
It's pretty humbling when you think about it. Nature often has the answers, if we just know where to look.
Absolutely. We call it biomimicry, taking cues from nature to solve human problems. And reducing drag, that's a prime example. We've learned a lot from those natural designs.
This whole deep dive has been eye-opening. Friction is everywhere, and it affects everything. We've seen how to increase it for better grip, decrease it for a smoother movement. But is it ever possible to, completely eliminate friction?
That's the million-dollar question, isn't it? I mean, we've gotten really good at reducing it with lubricants and streamlining and all that, but completely eliminate it, that's a tough one.
How come?
Well, remember those tiny imperfections, those microscopic bumps and ridges we talked about? They're always there, even on the smoothest surfaces. It's like trying to perfectly flatten a crumpled piece of paper. You can try your best, but those tiny wrinkles, they'll always be there.
So even if something looks perfectly smooth to our eyes, it's a whole different story at the microscopic level.
Exactly. Plus, you've got to factor in air resistance, too. Even in a near-perfect vacuum, like outer space, there are still a few stray gas molecules floating around. And you guessed it, those can cause friction, too. Minuscule, but still there.
Wait, so even in the vast emptiness of space,
Yeah.
there's still friction? Mind blown.
It's true. And over time, even that tiny, tiny amount of friction can add up, especially for things like satellites orbiting the Earth. They actually have to make these tiny adjustments every now and then just to counteract that teensy bit of drag and stay on course.
Wow, I never would have thought about that. It just goes to show these fundamental forces of the universe, they're everywhere, even in the most unexpected places.
Exactly. And it just speaks to the sheer complexity of the natural world, wouldn't you say? The more we learn, the more we realize we don't know. It's pretty amazing.
Absolutely. This has been an awesome deep dive into friction. We've gone from the basics to some pretty mind-blowing stuff, even touching on cutting-edge research in nanotechnology. But before we wrap things up, I'm curious, what are some of the areas of friction research that you're most excited about these days?
Ooh, good question. One that really fascinates me is what's happening at the nanoscale. See, at that level, we're talking incredibly small. The laws of physics, they don't always play by the same rules.
Oh, really?
Yeah, it's a whole different ballgame down there. And figuring out how friction works at that scale, it could lead to some groundbreaking discoveries, especially in material science and nanotechnology. Imagine engineering materials with almost zero friction.
That would be incredible.
Think about the possibilities. Microscopic machines, surfaces so slippery they make Teflon look like sandpaper. It's a whole new frontier.
That's some seriously futuristic stuff. It sounds like when it comes to friction, we've still got a lot to learn.
Oh, absolutely. We've come a long way in our understanding, but there's always more to uncover. Friction is full of surprises, and it's a constant source of scientific inquiry. And who knows what incredible technologies and innovations we might unlock in the process.
I'm excited to find out. We've covered so much ground in this deep dive. From the basic definition of friction to its many forms and applications, even touching on those cutting-edge areas of research.
It's been quite a journey. We've seen how friction impacts our lives every day, from the simplest tasks to the most complex technologies.
But before we sign off, let's take a moment to recap those key takeaways from our exploration into the fascinating world of friction. All right, so let's see if I've got this friction thing down. We're talking about that invisible force acting between surfaces, always working against that motion, right?
You got it.
And we saw how the texture of those surfaces really matters. Rougher means more friction. Plus, we dug into how friction can be both a friend and a foe depending on the situation. We need it for everyday stuff, like just walking around or picking up a cup of coffee. But it can also wear things down, create that annoying heat, and make moving heavy objects a real workout.
That's friction for you. A real multitasker.
And we can't forget about all the cool ways we've figured out to manipulate it to our advantage.
Right.
Like adding those grooves to shoes and tires for extra grip, or using lubricants to cut down on wear and tear in machines. We even talked about streamlining shapes to get around that pesky drag.
It's pretty amazing when you think about it. We've learned to work with friction instead of just fighting against it all the time.
And we even went beyond just solids, right? We dove into that whole world of fluid friction, that drag force that affects everything from swimmers to airplanes.
Even in space, remember?
Oh yeah, that's right. We had that mind-blowing moment where we realized that even in the vacuum of space, there's still a teeny tiny bit of friction happening.
Mind-boggling, isn't it?
It really drives home the point that friction is everywhere, influencing everything around us in ways we probably don't even realize half the time.
It's a fundamental force of the universe, and the more we learn about it, the more we realize just how much we don't know. There's always something new to uncover, which is what makes it so fascinating.
Absolutely. And speaking of uncovering new things, you mentioned some really cutting-edge research in nanotechnology. It sounds like there's still a lot to explore when it comes to friction.
Oh, definitely. We've made some incredible strides in understanding friction, but there's always more to learn, especially at those incredibly tiny scales where the rules of the game can change completely. It's a whole new frontier of scientific discovery.
I'm excited to see what the future holds for friction research. Who knows what incredible breakthroughs are just around the corner.
Exactly.
Well, I think it's safe to say that we all gained a newfound appreciation for this often overlooked force that shapes our world in countless ways.
It's been a pleasure diving into this with you.
The pleasure was all mine. A huge thank you to our expert for joining us on this journey into the fascinating world of friction. And to our listeners, thank you for tuning in to The Deep Dive. Keep those questions coming, keep exploring, and we'll catch you next time for another deep dive into the wonders of science.